So we are going to start with the elastic constants. So it is a simple topic where generally engineering service examination minimum 2 questions. Any of the competitive examination at least minimum 1 question will be there. GATE examination also you are getting at least 1 or 2 questions. If you see all the previous papers of both GATE and ESC, almost 150 questions are available or more than that one will be there on the elastic constants. Regarding this one, we already studied elastic constants when you have studied the homogeneous and isotropic material. Number of elastic constants are 4, E, G, K, mu. Now I am going to give the exact definition. First of all, what is the necessity of elastic constant? This also you have studied. Theoretically, stress can be determined, but strain is determined experimentally. So to determine the strain theoretically, we need the elastic constants. So now, what should I mention? Elastic constants are used to determine the strain theoretically, or they are used to obtain a relation between stress and strain. So number of elastic constants are 4 for a homogeneous and isotropic material. Elastic constants are used to determine strain theoretically. Are used to obtain stress-strain relationships. For a homogeneous and isotropic material, number of elastic constants are 4. E, G, but some of the textbooks they are using C, G or C, K, mu. E stands for Young's modulus or modulus of elasticity. Young's modulus or modulus of elasticity. Shear modulus or modulus of rigidity. Shear modulus or modulus of rigidity. Bulk modulus Poisson's ratio. Used to determine longitudinal strain under uniaxial state of stress. Under uniaxial state of stress. Longitudinal strain and lateral strains are valid under uniaxial state of stress. Used to determine shear strain shear angle, shear strain or shear angle under pure shear state of stress. So if this definition should be clear, you should be thorough with the state of stresses. But in all the textbook they are going to discuss this now. And state of stress is studied in the another chapter now. But all these definitions are discussed in the first chapter. But without knowing the state of stress, these definitions, there is no meaning now. It is valid under uniaxial state of stress. This is valid under pure shear state of stress. This is obtained from the slope of stress strain curve, which is drawn by using tension test reading. This is obtained from the slope of shear stress for shear strain curve, which is drawn by using torsion test readings. But every material tension test is conducted, we know E. But this is every material torsion test is not conducted, G is unknown. Hence the G is determined by using the relation between elastic constants. And this is used to determine volumetric strain under hydrostatic state of stress. It is valid under hydrostatic state of stress. Just now you studied now. But everybody knows the bulk modulus, but they don't know what the hydrostatic state of stress. That's why I discuss this now. That's why these definitions are not discussed in the starting. By that time, we are not studied the state of stress. So all these are going to be definitions are clear. Those you have studied all the state of stresses now. And this is used to determine the Poisson's ratio. Or what is the name for Poisson's ratio? lateral strain. This is to determine lateral strain. Used to determine lateral strain or transverse strain. This is valid under uniaxial state of stress. It is also valid under uniaxial state of stress. This is valid under pure shear state of stress. That is sigma x, sigma y 0, tau x y equal to tau. Uniaxial means sigma x equal to sigma, sigma y and tau x y 0. And this is hydrostatic state of stress. That is sigma x, sigma y, sigma z are equal and like in nature. Just now you studied now. Hydrostatic, it is valid under hydrostatic, that is triaxial. Sigma x, these two are under uniaxial. Pure shear means biaxial state of stress, but this is a triaxial. But there are so many triaxial. But what is the specialty of this now? Sigma x, sigma y, sigma z are equal and like in nature. And tau xy, tau xz, tau yz are going to be 0. So number of elastic constants are 4. But independent elastic constants are only 2, E and mu. For every material we know Young's modulus, because every material tension test is conducted. Then after conducting the tension test, the stress strain curves are drawn. So from the slope of the stress strain curve, sigma versus longitudinal strain curve, you will get the E. And by determining the lateral strain, we can find out the Poisson's ratio. So for every material, E and mu are known, but G and K are unknown. They are obtained by using the relation between elastic constants. Number of elastic constants are 4, but independent are 2. Independent are 2. For a homogeneous for a homogeneous and isotropic material, number of independent elastic constants, they mean like this now, IND dot independent elastic constants are 2. E and mu. E and mu. So total elastic constant means 4. But sometimes the question is what now? Number of elastic constant to obtain stress strain relationship means you have to go for E and mu. Out of 4, 2 is known. The remaining 2 are going to be determined by using relation between elastic constants. But your syllabus having only homogeneous isotropic material. But they are also asking some of the examinations, especially engineering service examination, objective paper, no, prelims paper. Always they are going to deviate from the syllabus. Mains examination, they are going to stick to the syllabus. There will not be any variation. So always objective examination of engineering service prelims. Always they are going to deviate from the syllabus. Every year what now? At least what, a 10 to 12 marks, 10 to 15 marks out of the 300 marks now. They are going to deviate from the syllabus. But mains examination, they are going to stick to the syllabus. Gate examination, almost 99.99% is going to stick to the syllabus. Only engineering service prelims paper, they are deviating the syllabus. So even though your syllabus having homogeneous isotropic material, but they are also asking what in the subject, what the assumptions they made now, homogeneous isotropic now. But some of the exams they are asking for anisotropic material as well as what now, orthotropic materials. So now what I'm giving the independent elastic constants for anisotropic and orthotropic material. Simply remember the independent elastic constant values. What are they? You need not focus now. That is not as per the syllabus, but you should know the definition. Already you studied the homogeneous, non-homogeneous, isotropic, anisotropic. This all you have studied now. Independent elastic constants. Default you are assuming the homogeneous and isotropic number of independent elastic constants are 2. Orthotropic, so what is that 9? You need not focus. Try to remember that number only. That 9 you need not bother. It is not as per the syllabus now. But you should know the definition of orthotropic. Don't waste your time on focusing on unnecessary things now. Focus only on the things which are going to be required to clear your, to get a crack your gate and ESC. What is required, that only focus. Unnecessary things you don't try to don't do the research now. You can do all this research once you have joined. Those who want to do the research, you can do the MS from IITs now, IIT Bangalore now, where you can do the research. Now your aim is to only enter into the IITs or IIT Bangalore or PSUs are going to be there now. So don't try to do the research during your preparation. I'm going to mention this not as per the syllabus, but only some of the exam they are asking. So for that one, I'm giving this information now. Orthotropic is 9, anisotropic is going to be 21. So already studied the isotropic you have studied, anisotropic you have studied, but orthotropic you have not studied. Orthotropic is also one type of anisotropic material. A material is said to be anisotropic when it exhibits different elastic properties. In orthogonal mean mutual perpendicular directions at a given point. Anisotropic, what you studied, anisotropic direction to direction, anisotropic direction to direction properties changes, but here orthogonal direction, mutual perpendicular direction changes now. Example is any layered material like plywood and graphite. Plywood as well as graphite. Now I am giving a generalized tabular form for all the 4 elastic constants. If you ask this, if you ask this Young's modulus definition in every batch, not a single student is going to give the exact definition of the Young's modulus. 50% of students are stress by strain, and remaining 50%, 20% are normal stress by normal strain, and remaining 25% is going to be normal stress to longitudinal strain. All these definitions are incorrect now. So what the exact definition of longitudinal strain? What the Young's modulus definition? I already given what orthotropic material. See the definition, but I written anisotropic or orthotropic, check it. We have studied orthotropic only, no? What the definition is given, orthotropic or anisotropic, all of you check it. Anisotropic already have studied. Orthotropic material is a material which exhibit different elastic properties in orthogonal directions. Anisotropic means direction to direction it changes. In the definition what I given, orthotropic are given or anisotropic? Anisotropic already have studied. Anisotropic, it changes from direction to direction. At a point, how many directions are there? Infinite direction. Orthotropic means it will changes in the perpendicular direction, orthogonal directions. A material is said to be orthotropic when it exhibits different elastic properties in orthogonal directions. Anisotropic means what we have studied now. A material should be anisotropic when it exhibits different elastic properties. There what the properties are changed from direction to direction. At a point, how many directions are there now? Okay, sorry. Probably I written as anisotropic, change it to orthotropic. Small correction. Probably in the I written as anisotropic, change the definition to orthotropic. Change that word, probably small correction is required. You change that anisotropic to orthotropic. All of you vote now. Change that anisotropic to orthotropic. I don't know, somewhere where missed it. Okay. So once I am informing, please make a correction. Whatever I written is a orthotropic material, not anisotropic. Anisotropic already I studied. Anisotropic means direction to direction it changes. So I'm once again defining the orthotropic material. A material is said to be orthotropic when it exhibits different elastic properties in orthogonal directions at a given point. Make a correction that anisotropic, you change it to orthotropic. Somehow it was miscorrection is there now. Okay. Satya has given definition under uniaxial state of stress up to proportional limit. It's the ratio of normal stress to longitudinal strain. Absolutely correct, my dear friend. Mr. Satya has given exact definition. So all these definitions are up to under uniaxial state of stress. Already I am written the another column for state of stress, therefore directly I am writing here. Slightly interchange these two columns now. This you make it as the first, this you make it as the second. Change these two columns, interchange it now. So this is valid under uniaxial state of stress. Next, up to proportional limit. Already you have studied the proportional limit. All this definition you have studied now. Proportional limit definition already given now. Proportional limit is the maximum stress up to which material obeys Hooke's law, or stress strain relationship is linear. Already given this definition. Check your notes now. Up to proportional limit. PL means proportional limit. It is the ratio of normal stress and longitudinal strain, and it is obtained from slope of Slope of stress strain curve up to proportional limit. PL is the proportional limit. So it is used to determine under so if you ask the definition, what should I give it now? Under uniaxial state of stress up to proportional limit, Young's modulus is the ratio of normal stress and longitudinal strain. Normal stress and longitudinal strain. Somebody will ask, no, sir, is sigma x or sigma? Uniaxial means normal stress there only in one direction. Normal stress there only one direction. Directly can write down sigma only. Under uniaxial state of stress. This is but how many pure shear state of stress you have studied? 3. But this is obtained from the torsion test. Torsion test is conducted under pure torsion. Therefore here if somebody why your uniaxial means this is obtained from the tension test. Tension test is conducted pure axial loading. Pure axial load means normal load is applied only one direction. Why the pure shear state of stress means it is obtained from torsion test. Torsion test is conducted a pure torsion. So on the cross section you are getting only torsional shear stress. Sigma x and sigma y 0. Proportional limit. Shear stress and shear strain. Last class itself you have studied now shear strain. Shear strain is a change in initial right angle between two line elements parallel to x and y axis. Shear strain nothing but a shear angles. Actual definition shear strain, but shear strain equal to shear angle. So sometimes they are writing shear angle, they are also writing now. In place of shear strain they are writing the shear angle. If I am taking the tau xy, it is going to be gamma xy. We are considering default x and y phase. Similarly, if you take the x and z phase, what should I write now? Sigma x equal to sigma z is equal to 0, tau xz equal to tau. Then what should I write now? Tau xz upon gamma xz. If you take the yz plane means pure shear state of stress means sigma y and sigma z 0. Then you have to write down the tau yz. So when you are taken tau yz, you have to take the gamma yz. What is the expression for sigma under tension test P by A? What is the expression for this tau we have studied? T T by Zp 16 T by pi d cube, T by Zp torsional shear stress. So slope of shear stress for shear strain curve up to proportion limit. There are three types of pure shear state of stress. Generally pure shear means sigma x plus sigma y 0. But default pure shear state of stress means you have to go for this example. What are the other two examples you have studied now? Sigma x equal to minus of sigma y and tau x y 0. Other one is what? A sigma x equal to minus of sigma y and tau x y is going to be non-zero. Bulk modulus. This is valid under hydrostatic state of stress. Under hydrostatic state of stress. Either biaxial, either uniaxial. This is going to be what now? Triaxial. But what is the specialty of the triaxial? How many independent components? 6. But here how many components are 0? No, 3 shear components are 0. Only all the normal stress are equal now. Normal stress equal and like in nature. If I write down the matrix, what the matrix you are going to get it now? Only diagonal elements, non-diagonal elements all are 0. So how to define the hydrostatic state of, mean what the answer now? A point is said to be under hydrostatic state of stress. A point is said to be under hydrostatic state of stress when normal stress in 3 mutual perpendicular direction, when normal stresses in 3 mutual perpendicular directions are equal and like in nature. Normal stress in 3 mutual perpendicular direction are equal and like in nature only. Only means what now? Shear stress are 0. This is valid in case of fluids. Which fluids now? Compressible fluids. Why this minus sign is there now? When the pressure increases, what happens now? Volume of the gases. Compressible fluid means gases. As the pressure increase, volume of the gas are going to be decreased. This is a compressive. So if I don't take the minus sign, the bulk modulus is going to become as a negative. EKG. EKG always should be a positive value now. EKG always this should be a positive for a deformable member. If some textbook in place of minus sign they are going to write down the mod, they are going to write down. So this is valid generally in case of solids. This is valid in case of compressible fluids. If I remove this minus sign, then you have to put the mod. As the pressure of the gas is what increases, the volume is going to be decreased. This is a negative. So denominator negative and negative will become the positive. So this is in case of compressible fluids. So up to proportionate, it is the ratio of hydrostatic stress. Since these are all equal, so this is called as what hydrostatic stress to the volumetric strain. Everybody is going to call the normal stress, but better to call the hydrostatic stress to the volumetric strain. This is in case of solids, in case of compressible fluids. So whenever the bulk modulus is infinity, the volumetric strain is going to be 0. Whenever bulk modulus is going to be infinity, volumetric strain is 0. If you ask the most of students directly what a bulk modulus, the bulk modulus used to determine the volumetric strain, but under hydrostatic state of stress. If you ask the 90 students now, 100 students, 90 students are bulk modulus, volumetric strain is determined by which elastic constant means they are going to give the bulk modulus. Bulk modulus not valid every time. Bulk modulus valid only under hydrostatic. When a bar is going to be pulled, length will increase, diameter is going to be decreased, volume is going to be changes now. Volume is going to be increased. The first day you have studied now. When a bar is going to be pulled, MSQ question now. When a bar is pulled, volumetric strain is going to be a tensile. So how to find out the volumetric strain means bulk modulus, they are going to tell it now. When a bar is going to be pulled under pure axial loading, bulk modulus is not valid. Bulk modulus valid only under hydrostatic state of stress. Mu, Poisson's ratio. Here proportional limit is not required because these are all what the ratio of the stress and these are all the slopes now. They're all valid for proportional limit, but this is the ratio of the lateral strain and longius strain. So mu is the already starting you discussed longius strain, lateral strain clearly studied now. All the definitions I already written now. It is the ratio of lateral strain to longitudinal strain. What is the name for lateral strain? Transverse strain. So once again, why the minus sign will be there now? Both are going to be unlike in nature. When a bar is going to be pulled, length is going to be increased, longitudinal strain is the tensile, lateral strain is going to be a compressive. So minus will become as a positive. Most of the time, for most of the material, mu is going to be a positive. Mu is a material. Very few material, mu is going to be a negative. So default you are taking as about mu is a positive. But few materials, mu is going to be a negative. Like foam as well as what a thermosetting plastic, the mu is a negative. This is not valid here now. To determine lateral or lateral strain under uniaxial state of stress. So to determine the Poisson's ratio, how many strains are required now? Both lateral and longitudinal strain. This is going to be obtained by using Young's modulus. Once just now you have written now, Young's modulus is to determine the longitudinal strain. So once you know the longitudinal Young's modulus, this is known. Then this is going to be obtained by using the strain gauges. Lateral strain is determined by the strain gauges. Longitudinal strain is obtained with the Young's modulus. Then you can get the Poisson's ratio. So to determine the lateral strain, how to write in the lateral strain? Mu multiplied by longitudinal strain. Mu multiplied by longitudinal strain. So to determine the lateral strain, how many elastic constants are required now? To determine the lateral strain, only Poisson's ratio required or longitudinal strain is also required? Longitudinal strain is also required. But to determine the longitudinal strain, what is required now? Young's modulus required. Therefore, overall to determine the lateral strain, we need the both E and mu. Both E and mu. When only mu is sufficient now. When longitudinal strain is known. But to determine the longitudinal strain, we need the Young's modulus. Already first day or second day we had done a question on this now. So this is determined by using this longitudinal strain is determined by using Young's modulus. Longitudinal strain is determined by using Young's modulus. In one of the paper it is given lateral strain is determined by which elastic constants. First option Poisson's ratio, second option Young's modulus, G, E and mu. Both you have to write required both E and mu. But there is no option of E and mu, then you can go for mu. So to determine the longitudinal strain we need the Young's modulus. So overall to determine the lateral strain we need the two elastic constants are required, both E and mu. pure shear mentioned, Mr. Satya, you need not mention biaxial. Once you have mentioned the pure shear means obviously it is the biaxial only. You need not mention the biaxial is not required now. Always what a pure shear means is going to be a biaxial. You need not mention the biaxial. Maybe the prime symbol is hiding. Lateral strain, write down here now. Those who are what now unable to what that because made the logo prime symbol logo. Last column you write down now. It is used to determine lateral strain or transfer strain. Lateral or transfer strain under uniaxial state of stress. The last column I am repeating. Somebody is what now? Sir, we are unable to see because of the made the prime logo. Write down this now. Poisson's ratio used to determine the lateral strain or transfer strain under uniaxial state of stress. Even under bulk modulus also you need not mention triaxial. Obviously hydrostatic state of stress is triaxial only. Whenever you mention hydrostatic, you need not mention the triaxial. And similarly, under pure shear also, you need not mention biaxial. Anybody vote now? Can you give the what the Young's modulus definition in this example? A block, rectangular block is going to be pulled in three perpendicular direction, px, py, pz. A rectangular block, just like a duster. Now this is pulled in what towards left and right, top and bottom, and front and back side. Front and back side. Now in this case, what the Young's modulus definition? Anybody know? Anybody got the Young's modulus definition? For this given loading condition, what the Young's modulus definition? Any of you know? What the Young's modulus definition for this particular loading condition? Mr. Anurag Roykwar, not valid. Bipin Kumar, under triaxial state of stress. For this, I need an answer. Sinha, sir, E only valid under uniaxial. This is a triaxial state of stress, means it is not valid. All phases have different Young's modulus. It is valid under uniaxial state of stress. It is generally a standard interview question is there now. So in the initial classes when I discuss the Young's modulus, Mr. Ankit Kishore, sigma x upon longirus strain in x direction. Under triaxial state up to proportion limit, normal stress to lateral strain is Young's modulus. How? Satyam Gupta, how you are taking lateral strain? Young's modulus give the longirus strain or lateral strain? Longirus strain one direction to longirus strain in the respecting direction. Ratio of normal stress to summation of one longitudinal strain due to Px, Py, Pz. Sir, volumetric strain is here. Here mu and is are there. Satya, sigma x equal to sigma y equal to sigma z is equal to sigma. How? Sigma x equal to sigma y equal to sigma z equal to sigma, Mr. Satya? Sir, Hooke's law is valid. Px is not equal to 0. Py equal to Pz. We have to assume it as about now superposition principle. Young's modulus valid under uniaxial state of stress. Young's modulus valid under uniaxial state of stress. But your stress is developed in three direction. Is a triaxial state of stress. But Young's modulus valid under uniaxial state of stress. First you assume Py and Pz are 0. Py and Pz are 0. Only Px is there. When only Px is there, what happens now? Uniaxial. Then what the Young's modulus now? Ex is equal to sigma x upon longirus strain in x direction. Probably one friend is given now. Similarly, when only Py is there, these two are 0. It is a uniaxial. When load is acting only in one direction, it is a uniaxial. So in that case, Ey equal to what? The Py upon longirus strain in z direction. Next, assume only Pz is acting alone. Then Ez is equal to, Ez is equal to sigma z upon longirus strain in z direction. The triaxial state of stress, you are going to get the what now? Stress develop in the three direction. If you take a cube here now, if you take a point now, So when this point is on x face, we are going to get the stress due to px, that is the sigma x. Next, when this point is on y face, due to this one, you are getting sigma y. And when this point is on z face, due to pz, you are going to get the sigma z. So it is the triaxial state of stress. And this dimension the length, what the area of this face now, b into t, what the area of the top face, l into b, what the area of the front face, l into t. If these are all equal, then it is hydrostatic. But the triaxial, but Young's modulus definition not valid. Then what do you do it now? Assume first these two are 0. That is, we are assuming the py and pz are 0. Then only sigma x is uniaxial. Then you can use your Young's modulus definition. So assuming Ex is equal to so this is, that is Px is non-zero. What the longitudinal strain definition is studied now? Normal strain in the direction of the load. Only load is there about a py. When the load is acting in y direction, the strain in the y direction is called the longitudinal strain. Longitudinal strain in y direction. Similarly, Ez is equal to now finally what the Young's modulus definition. Shall I use the first one or second one or third one? All are same because we are using the isotropic material. Isotropic material means what we have studied now. Young's modulus in all the directions are same. Since we are assuming the isotropic material, Ex, Ey, Ez and E at an angle of theta is same. So finally E is equal to what the definition now? Sigma x upon longitudinal strain x direction, or sigma y upon longitudinal strain in y direction, or sigma z upon longitudinal strain. So what the definition? For an isotropic material, Ex equal to Ey equal to Ez is equal to E theta, which is equal to E. Hence, E is equal to the Young's modulus definition now. But most of the students are going to give what now? Sir, sigma x by epsilon x, sigma y by epsilon y, sigma z and epsilon z. In this direction, how many strains are there? Total how many strains are going to be there? Due to this one, 3 strains. Due to this one, 3 strain. Total strains you have studied the 9. In this direction, total how many strains are? 3 strains. Due to px, longirus strain. Due to py, y direction longirus strain, but x direction lateral strain. And due to pz, z direction longirus strain, x direction lateral. So total how many strains are in x direction? 3. 1 longitude and 2 lateral strain. 1 longirus strain due to px, 2 lateral strain due to py and pz. But everybody is going to tell sigma x by epsilon x. We should not mention what now? Because in this direction there are 3 strains are there. Due to px in x direction longirus strain. Then y and z lateral strain, and due to py, y direction longirus strain, x and z lateral. Similarly, due to pz, z direction longirus strain, x and y lateral. So total how many strains are in this 3 now? Most of them are going to mention sigma x by epsilon x. We should not use the epsilon x. In x direction there are 3 strains are there now. Longitudinal, 2 lateral strains are there now. Most of the students they are going to give the definition like this now. This definition is incorrect now. Because x direction there are 3 strains are there. Due to px longirus strain, due to py and pz lateral strain. Starting clearly mention all are written now. So since you know always theoretically what you can find out sigma x, always numeric theoretically what strength of material what a theoretical subject. You know the load and width, and always load is known, dimension you can find out the sigma x. So you know sigma x, you know Young's modulus, then you can find out the longirus strain. Then lateral strain how to find out now by using Poisson's ratio. And due to this Young's modulus, you can find out the longirus strain in y direction. And we can find out the longirus strain in z direction. This was not my question now. I have given only Young's modulus definition I have given in the class now. Under uniaxial state of stress, it is a up to proportional limit, it is the ratio of normal stress to longirus strain. Maybe 10 years back, one of the friend is appeared in what a Bark interview now. So this was the question is asked, sir. Sir, you have mentioned it is valid under uniaxial state of stress, but they ask, I mentioned it is this definition is not valid under triaxial. I have already in the problem question also. but he has not gone through the class note, but he has mentioned, sir, it is valid. My sir is mentioned. Young's modulus valid only under uniaxial state of stress. Is a triaxial state of stress, it is not valid. But they are not accepted now. So, but I done the question on similar questions, I done it, but he has not gone through the definition. So those you are thorough with the definition, then I can answer it now. Superposition. Superposition means we are assuming the each load is acting alone. First I am assuming the Px acting alone, then Py is acting alone, Pz is acting alone. When Px, Py, Pz acting alone, they are the uniaxial state of stress. Generally, there is a standard question under tension test. What the expression for Poisson's ratio? Tension test. What the expression for Poisson's ratio? What the Poisson's ratio definition is written now? Lateral strain upon longuer strain. Tension test is conducted under pure axial loading. Sometimes this type of questions also going to be given directly. They are giving the change in diameter. EKG, always they are positive, greater than 0. But mu may be either positive or 0 or negative. But most of the material, it is a positive. Mu is equal to 0, you have studied for cork. Cork mu is going to be 0. But few materials like foam as well as thermosetting plastic, the mu is going to be a negative. Most of the materials, mu is going to be a positive. This is for cork. When mu is 0, what you have studied now? Lateral strain is 0. Lateral strain is 0. few materials like foam and thermosetting plastics. Generally homogeneous isotropic material mu is going to be positive. Hence mu limits are going to be what? -1 to half. Upper limit is a half. Upper limit is a half. Never mu will be more than half. If mu is more than half, bulk modulus will be negative. Mu should not be more than half. If mu is more than half, bulk modulus is going to be negative. So upper limit is a half and lower limit is -1. Is a generalized one now. Sir, in the exam, shall I take the first one or second one now? If simply is given what now? Which of the following option represents the limit for Poisson's ratio? When type of material is not mentioned directly, can go for this now. If homogeneous isotropic material means directly can go for this now. When type of material is not mentioned, it can go for this as generalized now. This should be considered when type of material is not mentioned. Simply ask what without mentioning the material. What the limit for Poisson's ratio? Then you can go for this now. -1 to half. K may be infinity. K may be infinity. But E, G and mu are not equal to infinity. E, G and mu are never will be infinity. K may be infinity. If K is infinity means what now? If K is infinity means your change in volume is 0. But never Young's modulus infinity. If Young's modulus infinity, what happens now? If Young's modulus infinity means that is a what now? Longirus strain is 0. When longirus strain is 0, that is a rigid body. So we are all default studying for what? Deformable bodies. They are all what? For default starting you studied now. Elastic bodies. For elastic bodies, K may be infinity. K is infinite means what? A volumetric strain 0. Volumetric strain 0 means change in volume is 0. Change in volume may be 0. But longirus strain never will be 0. If longirus strain 0 means the rigid body, when E is equal to infinity, for rigid body, E and G are infinity. But for deformable bodies, K may be infinity. K may become infinity. But E, G and mu are not infinity. Here change in volume is 0 means what now? Change in dimensions are 0 or non-zero. Change in volume is 0 means change in dimensions are not 0. Overall volume is 0, but change in volume is 0 means, sir, when change in volume is 0 means a rigid body. Change in volume is 0 means it's not a rigid body. Change in volume is dependent upon length, width and thickness, all are going to be there now. So change in volume 0 means change in dimensions are not 0. When a sheet metal passing through a rolling mill, what happens now? Overall volume is going to be what? A change in volume is 0, but dimension will change now. Same thing, what? A change in volume is 0 means everybody is going to assume change in dimension 0, then is a rigid body. Change in dimension will be there, but overall volume will remain same. Length will increase, width and thickness decreases, overall volume is going to be same, but dimensions will change now. Now, when mu is negative, what's the difference between mu is positive and mu is negative? When mu is negative, then that materials are called as what? Anti-rubber. What's the meaning of mu negative now? Mu is negative means what the meaning now? Longirus strain, lateral strains are going to be like in nature. Mu is going to be negative. When this value will be negative, when both are going to be like in nature. So what you have said, longirus strain, lateral strains are unlike in nature. That is possible when mu is going to be positive. But when mu is negative, what happens? Both are like in nature. Generally, when a bar is going to be pulled, what you have said, length will increase, width and depth are going to be decrease. Longirus strain, lateral strains are unlike in nature. That is possible when mu is positive. But when mu is negative, what happens now? Mu is negative. When this will become as what? This value is going to become as negative. When both are going to be positive or both are going to be negative. When this ratio is going to be a positive. When this ratio is a positive, then positive into what? A negative will become as negative. But if this ratio is a negative, negative into negative will become as a positive. So what is the difference between mu is positive and mu is a negative? Mu is a positive and mu is negative. When a mu is positive means longirus strain and lateral strains are unlike in nature. When mu is negative, what happens? Longirus strain, lateral strains are going to be like in nature. So means when a mu is going to be negative means what now? Length increases, depth, diameter also increases now. But this is not possible to imagine now. But that is possible only in case of foam as well as what? Thermosetting plastics. That's why they are called the anti-rubber. Generally rubber means what now? If I am going to pull it, length will increase, width and depth are decrease. Anti-rubber means is behaving what now? opposite to rubber. Generally rubber means what? If I am going to pull it, length will increase, width and depth are decreases. So anti-rubber means what? When I am going to pull it, length will increase and width and depth also increases. So those materials are called as what? Anti-rubber. Both longitudinal strain and lateral strains are unlike in nature. Because everybody is going to mention they are unlike, because default mu is a positive. Every material, about a very few material mu is going to be a negative. When mu is called as, these materials are called as what now? Anti-rubber. Or they are called as a dilational material. Dilational. What is the volumetric strain definition now? Volumetric strain, other name is a dilation. Now which one is going to exhibit the more change in volume? Which one will exhibit the more change in volume? In this case, length increases, diameter increases. Both are increased. Therefore, they will exhibit the more change in volume. Here, length will increase, diameter is going to be decreased. Therefore, they will exhibit the less change in volume. So, this will exhibit the more change in volume. More change in volume. Sorry, 1 minute. Less change in volume. Or what you can call it, they will offer less resistance to, or more exhibit less change in volume in what now? They will exhibit the more resistance to change in volume. And they are exhibiting more change in volume in what? They are exhibiting what now? Less resistance to deformation under normal loading now. Volume changes depend upon the normal loads. So these material will exhibit more resistance to deformation under normal loads. And they are exhibiting more change in volume in what? They will exhibit less resistance to deformation under normal loads. Exhibit more shear deformation. This is only for your some type of interview point of view, what the difference between mu and when mu is positive and mu is negative. When mu is positive, both are going to be longitudinal strain, lateral strains are unlike in nature. They are like in nature. They will exhibit the more less change in volume. Exhibit the more change in volume. and they will exhibit the more shear deformation, less shear deformation. The shear deformation value depend upon the G. So more shear deformation means what now? Here G is going to be what now? Less. For this material G is going to be less. When mu is going to be negative means what now? G is going to be more. When mu is going to be negative, G is going to be more. Shear deformation depend upon the shear modulus. So this material have the more shear modulus, and this material will have the less shear modulus will be there now. But some paper it is given that what now? One of the engineering service paper, mu is 0 means that Poisson's ratio of a material is 0. It means that mu is 0 means which one is 0? Now lateral strain is 0. That is what now Cork case is possible now. If this should become 0 means what? Either numerator should be 0 or denominator should be infinity. Something should be 0 means what? And either numerator should be 0 or denominator should be infinity. But generally which is possible now? Numerator is possible 0 because of what? For Cork lateral strain is 0, mu is 0. Longirus strain never will be infinity. When the longirus strain is infinity, rigid body, when E is infinity, what happens now? When suppose if you take the change in length is equal to PL by AE. So when E is infinity, what happens now? Change in length is 0. Then it is called as a rigid body. When change in length is 0 means longirus strain is 0. So here what should I consider now? If mu is 0 means which option you have to select it now? Lateral strain should be 0 or longirus strain should be infinity. Longirus strain should be infinity. But when the longirus strain is infinity, when this longirus strain is infinity, when E is going to be 0. When E is 0, what happens now? The change in length is going to be infinity. So practical is not possible now. So for rigid body, what the Poisson's ratio now? For rigid body, what the Poisson's ratio value? For rigid body, what the Poisson's ratio value? Rigid body means what now? Longirus strain is going to be what now? 0. Longirus strain, change in length 0 means longirus strain 0. For rigid body, change in length 0. Change in length 0 means rigid body is what? Change in length 0 means longirus strain 0. When the longirus strain is 0, what happens now? Poisson's ratio now? Infinity. So in the options are given like this, mu is equal to 0. Means either should be 0 mu is 0 means either lateral strength should be 0 or longitudinal strength should be infinity. But there is no option of lateral strength, 0 option is not there. Then you go for directly option, you have to consider longitudinal strength should be infinity, option should be considered now. Longitudinal strength should be infinity, should be considered. But this option is there and rigid body is given. If it is taken what a mu is 0 means rigid body. For rigid body, what the Poisson's ratio now? For rigid body means what? A longitudinal strain is 0. Longitudinal strain 0 means Poisson's ratio is going to be infinity. But in the question is given what? A Poisson's ratio 0. So you have to go for only this option now. If this option is available, you take it now. But that option is not there. Then you have to go for the longitudinal strain should be infinity, should be considered now. But most of the solution they has taken rigid body. Rigid body, the Poisson's ratio will become as the infinity. Poisson's ratio will become as the infinity. So I can put it like this now. For rigid body, E, G and mu are infinity. For rigid body, E, G and mu are infinity. But for deformable, never it is going to be infinity. ఇప్పటి నుంచి నడుస్తుంది. $758. 12 నిమిషాల నుంచి మైక్ లేదు, నేను చెప్పుకుంటూ పోతున్నాను. ఇప్పుడు మళ్ళా So sorry my dear friends, I didn't check it. The battery was what got discharged. I didn't check it. I hope you are able to hear my voice. The mic was on only, but the battery was got discharged, so that I was unable to identify that one. Maybe last 10 minutes you are unable to hear. Can you tell me now where exactly we have stopped it now? At which point you have got it now? Anybody can tell me when exactly, at which time? You are correct, Satya. The mic was on only, but only the battery was discharged. Before the start of the table. Okay. I hope this from the Poisson's ratio only. Okay. So I written the Poisson's ratio values. At least try to remember this now. For Cork, already I studied the mu is 0. When mu is 0 means lateral strain is 0. But I mentioned here now, when Cork should be selected. When Cork should be selected. So whenever I am pulling now, whenever I am pulling, only the dimension in the direction of the load should change. If I am pulling a member like this now, load is applied in one direction. So dimension should change only in the direction of the load. Other two direction dimensions should remain same. For example, a bar is going to be pulled. For me, only length should change. Width and depth should remain same. Then only one option is about a cork. If you use any other material, every longitudinal strain associated with the two lateral strains are there. So whenever I want to get the lateral strain should be 0. That is what now? That only I written now. Cork should be selected as the material in the application where dimension should change only in the direction of load. That is longitudinal strain should be non-zero, but lateral strain should be 0. Example is going to be a bottle stopper. Bottle stopper. What the function of the bottle stopper now? To prevent the leakage of the fluid. To prevent the leakage of the fluid. In place of the bottle stopper, if the bottle stoppers are what now? Manufactured or manufactured with a material other than the cork. If any bottle stopper is what manufactured other than the cork, what happens now? Leakage of the fluid will be there now. Hospital saline bottles, still hospital they are using the glass bottle, saline bottles are there now. All the glass saline bottles are closed with a cork of the material. If you use any other material, what happens now? The leakage of the fluid will be occurs now. So what the conclusion now? Whenever the dimension should change only in the direction of the load. So the dimension in a direction perpendicular to the applied load. Dimension in a direction perpendicular applied load should remain same. Then you have to go for cork the material. Then rubber. Rubber in all the textbook they are writing the Poisson's ratio the 0.5. It is not 0.5. Actual value is going to be 0.495. I am not remember the third decimal. It may be, this value may be 6 or 7 will be there. So it is very closer to 0.5. They are writing the 0.5. Rubber is not a perfect plastic. Since this value is very closer to 0.5, they are writing as a 0.5. 0.5 means what now? Perfect plastic or perfect incompressible material. So whenever mu is equal to what? A 0.5, volumetric strain is 0. Whenever what now? Whether it may be uniaxial or biaxial or triaxial, whatever may be the state of stress. Whatever may be the state of stress, whether it may be uniaxial or biaxial or triaxial, hydrostatic, any state of stress, when the mu is equal to 0.5, the volumetric strain is 0. In one of the gate paper, there is a question is given now. For perfect incompressible material, Poisson's ratio value is given by 0, 1, 0.5. Most of them are taken as a 0 now. 0 is for cork now. Then in that case what now? When mu is 0 means what? A volumetric strain is not 0. Mu is 0 means what? A volumetric strain is not 0. Lateral strain is 0 but longitudinal strain is there. When mu is 0 means what? A volumetric strain is not 0. Lateral strain is 0. Volumetric strain is non-zero because of when mu is 0, only lateral strain is 0, but longitudinal strain will be there. Longitudinal strain value depend upon the Young's modulus. Now I am going to give the relation between E, G, K, mu values now. Okay. Now you have studied for every material we know E and mu. K and G are unknown. So to get that K and G we need the relations. Now whatever the relations I am writing very important. Most of the time directly engineering service examination. They are asking about now relations only mostly. So whatever the relations I am writing, directly try to remember it. Most of the students are already familiar with these relations. With this relation, most of the students are familiar. So most of the time directly they are asking the relations. Otherwise, two elastic constants are given and third one has to determine it now. Relationship between elastic constants. Relationship between elastic constants. Some students are interested, sir, shall I focus on this derivation? Is not required, directly try to remember it. This derivation never they are asked, objective examination not required, even in the engineering service examination mains also never these derivations are there now. If anybody interested, you can go through the derivations. Sir, I'm interested, I want to know how these derivations or relations are obtained. You can refer the textbooks now. But I'm going for the all as per the examination which is required that we are going to discuss. So E is equal to 2g into 1 plus mu. If it is a small 4 or 5 step derivation that I'm going to do it now. Very lengthy derivations that we are not focusing now. Even in the engineering service mains examination, strength of material, you are getting only numerical questions are going to be there. Conventional questions are there. Never their derivations are there now. E is equal to 3k into 1 minus 2 mu. So these relations, almost 90% of the students are known now. E is equal to 9 kg upon 3k plus g. So try to remember these relations. What the first relation used now? Since you know E and mu, you can find out g. From this one you can find out k. And from this one what now? If you know out of these three now, E, k, g. Third one can be determined now. G is equal to E by 2 into 1 plus mu. G is equal to E by 2 into 1 plus mu. Now from this one you can see it now. You take any value of Poisson's ratio. You take any value of Poisson's ratio. G is always a positive. You take any value of what now? Poisson's ratio. Always G is positive only. K is equal to E by 3 into 1 minus 2 mu. K equal to E by 3 into 1 minus 2 mu. But here K the positive or negative depend upon the mu value now. Suppose if I have taken the mu is equal to 1, then this will be a negative. But K should be a positive value now. K should be a positive value. K should be a positive value. If the K should be positive, what the conclusion? Just now you have written what now? EKG. EKG should be always a positive values. So if the K should be positive means 1 minus 2 mu should be greater than 0. 1 minus 2 mu should be greater than 0 means mu should be less than or equal to half. So how we got that mu upper limit half from this only? If K should be positive, that's why you study the upper limit for Poisson's ratio is going to be half now. Upper limit for Poisson's ratio half. That's why what most of the material mu value lies between 0 and half. If type of material is not given, you are going for the mu is going to lie between minus 1 and half. Always upper limit is going to be half now. Upper and lower limits. K and G. Upper and lower limit for K and G in terms of E. in terms of E. Sorry, okay. Mu G Now can you write down this now? Limits are what? For mu is going to be lower limit is what? A 0, upper limit is half. Now can you write down this value? Now this will be E by 2, E by 3. This is E by 3. So from this table, what the conclusion I can make it now? From this table, what the conclusion I can make it now? As the Poisson's ratio value increases, G is decreasing but K is increasing. As Poisson's ratio increases, G will decrease but K will increase. One will decrease, one will increase. Next, what the limit for G now? G is always lies between G lies between E by 3 and E by 2. G lies between E by 3 and E by 2. But what about K? K is what now? Between E by 3 and infinity. K is going to be between E by 3 and infinity. So from this one, what you can mention it now? Always G is going to be less than Young's modulus. And less than what now? Half of the Young's modulus now. When exactly equal to half of the Young's modulus only in case of Cork. Other than Cork, always what a G is going to be less than the half of the Young's modulus. From this also one paper, what a question is there now? Shear modulus of a material. Shear modulus of a material. Which of them are correct with respect to shear modulus of a material? Greater than Young's modulus, less than Young's modulus, equal to half of the Young's modulus, less than or equal to half of the Young's modulus, less than or equal to half of the Young's modulus. For mild steel, what the Young's modulus here at 200 gigapascal, but G will be what now? Around 80 gigapascals. You are going to get it now. G will be around 80 gigapascals. So always what now? And always G is what? G is more or E is more? Always E is more. G will be less than or equal to half of the Young's modulus. Now E is more or K is more? We don't know. Here G is always less than E by 2. But K is more or E is more? You can check it now. Here which one is more now? K value is what? 1/3 of Young's modulus. Means K value is less here now. But here K is infinity. But never Young's modulus infinity now. Never Young's modulus infinity. So here which one is more now? K is more or E is more now? K is more. So some material, which one is more now? Some material Young's modulus is more. Some material bulk modulus more. Some material both are going to be same. So what the relation between E, K, G means what now? Always G is less than half of the Young's modulus. But what about E and K? Whether K is more or E is more mean what the answer now? Some materials Young's modulus is more than the bulk modulus. Some material both are equal. Some material K is more than E. never is greater than, never is infinity. When is infinity, what happens now? Is a rigid body. Just I written now. For deformable bodies, never Young's modulus infinity. For deformable bodies, never Young's modulus infinity. If Young's modulus infinity, it is what now? Is a rigid body. That only I written K may become infinity, but E, G and mu, never they are infinity. For some materials, initially which one is more now? E is more. E is more. K is less. So as the Poisson's ratio increasing, what a K is increases. At a particular value, both are going to be same. And some material E is or K is greater than E. Now can you write down this table for the metals now? For metals, for the Poisson's ratio range now 1/4 to 1/3. For metals, Poisson's ratio range is 1/4 to 1/3. Substitute what now? 1/4. This is what now? 0.4 E. Check it, these values now. This is 0.375 E. Mu GK. So what the conclusion now? Up to 1/3. Which one is more now? Up to 1/3. K is more what? E is more. E is more. Exactly 1/3. Both are equal. Just now I written now. Some materials what E is greater than mean what? If mu is what? Less than 1/3. If mu is less than 1/3, E is greater than K. If exactly 1/3, both are equal. If I go above 1/3, K is greater than E. That is, if mu is less than 1/3, mu is less than 1/3, E is greater than K. I'm not discussing the question, but I'm covering the topic in such a way that what based upon the class notes you can answer any of the question. Indirectly what so many times all these questions of the elastic constant you can complete, both engineering service and gate papers. Elastic constants you can complete it, except one question. There is what a very old engineering service paper. There a question is given a Lami's constant. That is not as per the syllabus. Only one paper, very old paper is given Lami's constants. Somebody is asking, sir, you mentioned you can complete any of the question, but I am unable to do it now. That is not as per the syllabus now. And if that is question is repeated several times, I might have discussed. Only one paper is given now. So because it is given, even if by chance it is included in the syllabus, I will cover it, but it's not there. It is given only one time. So because of one question, I don't want to waste the time now. Except lam is constant, remaining all the questions of elastic constants now you can complete based upon the class note. Not only objective question, but you can also answer all the interview questions also you can answer it now. In one paper directly is given, for a material, Young's modulus and bulk modulus are equal. If Young's modulus and bulk modulus are equal, when bulk modulus and Young's modulus equal means directly what now? Mu is equal to 1 by 3. Exactly 1 by 3 both are equal. Above 1 by 3. Above 1 by 3 K is greater. Below 1 by 3 is greater. So overall metal which is more now? Which is more now? E is greater than E is greater than K is greater than G. But if overall we cannot tell it now. Only for metals what you can tell it now. Young's modulus greater than bulk modulus greater than shear modulus. But that is what now? 1 by 4 and 1 by 3. Between 1 by 4 and 1 by 3 can tell it now. Otherwise what now? Initially what now? Here. If you go above 1 by 3, what happens now? K is more than E. So only for metals we can tell it E is greater than K is greater than G. The same question is given in the workbook. Now that is one of the GATE civil engineering paper. For structural steel means what? A mild steel. Ascending order of EKG. Ascending order is given. Then what you have read now? G less than K less than E. G less than K less than E. Ascending order is given now. Somebody will ask now, sir, can I take the equal to? Here both are equal now. But that is what? A 1 by 3. 1 by 3 means in the calculator it has considered as what? A 1. If you are going to substitute 1 by 3 in this relation now, the calculator will consider 1 by 3 as about a 0.3333 like that now. But if you substitute in place of 1 by 3, 0.33, check it, this value is going to be less than E will be there now. By chance, if there is an option is what? A given what now? E is greater than K, E is greater than or equal to K, K greater than, that we take it now. But generally that is not going to be there now. So generally you are going to take the, for metal which is more means what now? What the answer now? E is greater than K is greater than G. But when type of material is not given directly, we cannot tell it now. Independent of what now? Any value of what? A poison, any material, what happens now? Only you can conclude now. G is going to be less than half of the Young's modulus. Or E is greater than G, can tell it now. But what about E and K? Some material E is more, some material both are going to be equal. Some material bulk modulus is more. Still you are getting a problem. Video getting stopped and technical team being a proper network also refreshed. Technical team. This is getting irritating. Please. Are you getting any issue with that video? Mr. Satya is telling again video is getting stopped. Probably Satya, maybe it's your problem because remaining all the friends are what now? They are comfortable. They don't have any issue now. Check your from your end. Remaining friends, they are what now? There was no complaint from other friends now. So remaining friends are okay, Mr. Only Satya from your end you have to check it now. Here everything is okay. Remaining all the friends are comfortable. They also responded, sir, no sir, video is fine. If you have some time vote now from your end also, maybe problem will be there. Okay, thank you for all of you. So there are going to be, already you mentioned online, there are so many, some advantages or some disadvantages are going to be there. It is depend upon the, from this side also and from your end also. There are so many weather condition, there are so many issues are going to be there now. So everything else, some advantage, some disadvantages are going to be there. Afterwards, if anything you have missed in between from your end, if anything is what now missed, you can make a time at that time. Then afterwards you can, because you are having an advantage, what I can go through the recorded lectures now. It is not possible to go through the entire lecture 6, 7 hours is what a problem now. Wherever you are getting a doubt or wherever you are from your end there issue is there now, at that time you can make a note of that time and that you can go through that recorded lecture now. Okay. So this is about the elastic constant. Now all the questions you can complete based upon this now. I'm going to give the workbook. There are 3 or 4 5 questions are then, but now directly can solve the all the elastic constants questions of both GATE and ESC. I'm going to deliver my lecture in such a way that instead of discussing the question by question, I'm going to deliver my lecture in such a way that based upon the class note, the student should able to answer every question. So that's why what now I'm presenting in such a way that it is not from any of the textbooks now. Only by observing the what now? Previous papers. So instead of covering each and every, it's not possible to cover each and every question in the class. But I am going to deliver my lecture in such a way that the student should answer each and every question, any of the topics now. Okay. Let me complete the strain classification. We have studied the longitudinal strain, lateral strain, normal strain, shear strain. You have studied only volumetric strain. You have studied now. So let me write down the strain classification. This year also 2022 ESC prelims, that one question is there, that also complete it now. Always first complete the in the workbook and not included this year and last year work questions are not included now. But you can do directly from the class notes now. Classification of the strains. If I include the latest questions, that anyway you are going to get the latest questions are available. Old questions are, they are not going to be available everybody. Everybody is going to have the recent papers are available. 2022, 2021, 2020 papers are always available now. So that question directly can do it based upon the class notes. So in the workbook I kept only very old papers. Everybody will not have all the old papers. GATE, ESC and civil services now. So I kept like that only. So I already mentioned increasing the efficiency. You have to do the more practice. More practice. Instead of by-hearting 100 times now. With a one equation. Suppose that normal stress and shear stress equation. Instead of writing 20, 30 times now. With that equation, solve the questions now. Whatever the questions you are given now. If you do the more practice, definitely you are going to remember it all this now. And if you are going to more practice, then definitely you can increase your accuracy and efficiency. Only practice. More practice is required now. Some students are initially definitely, they may take some time now. But gradually what now? You have to increase your what now? As you do the more practice, then definitely you are going to increase your efficiency, you are going to increase this, and your fastness also you can increase it now. But if you don't do the practice, there is no use now. Simply go through the class notes. 1 hour you are going to review the class notes. Class notes is clear, my concepts are clear. If the concepts are clear, not the first concept should be clear, but you need a more practice. If you do the more practice, you can increase your accuracy and you can increase your fastness in calculations. And automatically all your concepts and formulas you are going to remember until your goal, till the maybe still 7 or 8 months are going to be there, 7 months, maybe in the month of January or February, those they are preparing for GATE. Almost 10 months time is going to be there. We can have the what now. So if you do the more practice, then definitely all the concepts as well as equations you will remember now. Do the more practice. Okay. What is the other name for volumetric strain? Dilatation, sometimes dilation they are calling now. Dilatation. Every year I'm going to write down, but never this word used in the exam now. But last year engineering service paper this word is used now, dilatation. So you should be familiar with all the multiple names now. All the synonyms you should be familiar now. What the other name for lateral strain you studied now? Transfer strain. Transverse strain. Tensile strain and compressive strain. Tensile and compressive strains. If the change in dimensions are positive, the tensile strain change in dimension negative. When you are studying that example principal strain chapter, no, one diagonal is elongated, other diagonal is contracted. Similarly, if the volume is going to be increased, the tensile strain, volume is going to be decreased, the compressive strain. All these definitions are written. You can check it now. Once I am not writing, starting itself I have written the longier strain, lateral strain. These are all you have studied. Shear strain also, yesterday I explained, but I have not written the definition. I will write down now. But these two are already completed. Number of longier strains equal to in how many direction loads are acting. This is all you have studied now. This I am not explaining once again. Only volumetric strain and shear strain you are going to study now. But what is the generalized definition of normal strain? Suppose the normal strain at an angle of theta means what you had read now. What is the definition now? In any direction equal to change in dimension in the direction. Original dimension in the direction. If the change in dimension or change in volume. If you go for a volumetric strain, what you read on a change in volume to original volume. If the change in dimension is positive, then this is a tensile strain. If the change in dimension is negative, is a compressive. The tensile when change in dimension or change in volume is positive and vice versa. What is the volumetric strain now? Change in volume upon but this volumetric strain can also be written as so this is the actual definition, but the volumetric strain is also equal to sum of the normal strain in three mutual perpendicular direction, algebraic sum. So this is the definition. Volumetric strain definition means change in volume to original volume, but the volumetric strain can be obtained by the sum of the algebraic sum of the normal strain in three mutual perpendicular direction. Volumetric strain is equal to algebraic sum of the normal strains in three mutual perpendicular direction. How we got it? Now mathematically, taking a volume and doing the partial differentiation. So this equation is valid under uniaxial state of stress or biaxial or triaxial or hydrostatic. No, any case is valid. But your bulk modulus equation valid under hydrostatic state of stress. But this is valid under any state of stress condition. And it is also valid even if the load is not also acting. Means even if the volume is also changed due to change in temperature also. Even if the temperature increases, volume is going to be changed. That is also valid now. It is a generalized equation. This is valid in presence of load and in the absence of load. In presence of load means what? Even under uniaxial state of stress, biaxial state of stress, triaxial state of stress, and even in the absence of stress. When there is no stress means when there is no load. Then how to get the change in dimension? Because of the change in temperature. Valid under any state of stress condition and under any state of stress condition and even in presence of change in temperature also. Is it a longitudinal strain or lateral strain or this one? If it is going to call this longitudinal, these two are lateral. When should I the longitudinal, lateral now? In case of uniaxial state of stress. But biaxial case a total strain. Triaxial case, each direction, how many strains are there now? Triaxial means load is in three direction. So longitudinal strains are three strains now. And lateral strains are 6. Total how many are studied now? 9. Each direction how many strains are going to be there now? 3. So in case of biaxial and triaxial, under biaxial and triaxial state of stress, it is called the total strain or net strain. If it is going to call the what now? Sir, what I mentioned, a volumetric strain is equal to algebraic sum of the normal strains in three mutual perpendicular direction. So what should I call this? Epsilon x, epsilon y, epsilon z. Under uniaxial state of stress, one will be a longitudinal, these two are lateral. But biaxial and triaxial state of stress, they are called as what now? Total strain. In place of the total strain, we can also use the net strain. In place of the total strain, we can also use the net strain. Rectangular block. So what is the volume of this block now? How to get a volumetric change in volume to initial volume? Now do the partial differentiation of this now. What is the partial differentiation of this equation? Now Now this is what length is in which direction? X direction. So this will become as epsilon x, and this is epsilon y, and this is epsilon z. Therefore, for the volumetric strain here written as epsilon x plus epsilon y plus epsilon z. Now, while getting this equation, have you considered any load now? No. That's why this equation valid what now? Even presence of load, even in the absence of the load. Even presence of the load means what? Whether load is acting in one direction or two direction or three direction. Even if what now? Load is not also, therefore I written what now? Valid under any state of stress condition, and even in presence of change in temperature, that is even in the absence of the load. Because this equation got just like mathematically, we are not considered any loading condition here now. But the bulk modulus equation valid only under hydrostatics. How to find out this epsilon x, epsilon y, epsilon z, E and mu? So if sometime the objective question will be there now, volumetric strain is determined. Volumetric strain is determined by using which of the elastic constants? Young's modulus, bulk modulus, shear modulus, and Young's modulus and Poisson's ratio. Young's modulus and Poisson's ratio you have to consider now. Bulk modulus valid under only hydrostatic, but the equation valid any case. So volumetric strain is determined by using which of the elastic constant? First option Young's modulus, second option shear modulus, third option bulk modulus, fourth option Young's modulus and Poisson's ratio. Then you have to go for option D. But 30% of or 50% of students directly they will take the bulk modulus. Volumetric strain means they will take the bulk modulus now. Bulk modulus valid only under hydrostatic now, but the equation valid any case. But these two are determined by what? By using E and mu. So volumetric strain, to determine the volumetric strain, we need the two elastic constant. What are they? E and mu. Suppose only volume changes due to change in temperature. Now what should I call the epsilon x, epsilon y, epsilon z? When should the word of longitudinal lateral strain? Now when load is there. Assume what? Now this rectangular block is heated. Because the heating, what happens? Length will increases, thickness will increase, width will increases. Then at that time this epsilon x, epsilon y, epsilon z are called as what? Thermal strains. So these are the longitudinal strain or lateral strains or net strain or thermal strain. Depend upon the condition. If only change in temperature is there. Only change in temperature means what? No, there is no longitudinal strain, lateral strain. Longitudinal strain, lateral strain should be used only when the load is there. When there is no load, we cannot use the word of longitudinal strain, lateral strain. There you should have the concept of thermal strain. If only change in temperature, then this is called as what now? Thermal strain in x direction, thermal strain in y direction, and thermal strain in z direction is going to be used now. Cylindrical bar. In this case, once again, what the volume now? Once again, if you do the partial differentiation, So when should I use this epsilon x, epsilon y? So the load is if this bar is going to be pulled, only axial load is the longirus strain. These two are the lateral strain. If only temperature change is there, then this is called as what? A thermal strain, thermal strain, thermal strain. But if the load is applied in more than one direction, when the load is applied more than one direction, this is called as what? Total strain, total strain, total strain, total strain, or what the other word now? Net strain. In case of cylindrical pressure vessels, thin cylindrical pressure vessels, CPV, delta L by L is called as the longirus strain. This we are going to study in the chapter number 9, pressure vessel chapter. And delta D by D is called as a hoop strain or circumferential strain. Hoop strain or circumferential strain. Hoop or circumferential strain. Then what the volumetric strain you can write down now. When I am studying about last chapter now, pressure vessel, I written this equation. Somebody said, how you got this relation? I already proved it here now. The things which are discussed once again, they are not going to be studied now. All the similar things I am going to explain at a time now. In case of cylindrical pressure vessel, volumetric strain equal to longirus strain plus 2 times the hoop strain. Spherical body, what the volume of a sphere now? 4 by 3 pi r cube or pi d cube by 6. Pi d cube by 6. And if we differentiate this now, so volumetric strain is equal to change in volume upon virginal volume, that is 1 by 2, that is 3 times delta D upon D. Three times the delta D upon D. In case of thin spherical pressure vessels, spherical pressure vessels, that is SPV. In sphere, there is no length, only diameter will be there. Sphere is a symmetrical object, then there is no longirus strain, only you are going to get a hoop strain. 3 times the hoop strain, that is the delta d by d. Eight hours you have to attend, my dear friend. Minimum 8 hours you have to attend it. Otherwise, it's not possible now. Syllabus completion will not be there. We have started at about 2 o'clock and 7 hours 15 minutes. Half an hour break has gone. 6 hours can't attend it now. Mr. Lokesh Sinha. Otherwise, it is not possible to complete the syllabus. And your online is going to take the more time, almost 50% more than the offline now. Maybe the prime batch students, they have attended online, so the syllabus will not be less now. Gate 2023, for everybody the syllabus is same. These are the online students, they opted for online, so syllabus will be less. Offline syllabus will be more, like that will not be there now. Everybody the syllabus is same. सर सॉरी टू से आपका क्लास कभी कभी ओवर टाइम हो जाता है, ह्यूमन कैपेसिटी से ज़्यादा होने लगता है. ह्यूमन कैपेसिटी इज व्हाट नाउ? आई एम ऑल्सो ह्यूमन बीइंग नाउ. आई एम टेकिंग द व्हाट नाउ 10 or 12 hours class now. You are sitting in the class and you are unable to sit 6.5 hours now. Then you should join the what now? 2 years program, you have to join it now. Six and hours can't to attend it now. Mechanical syllabus is more, vast is there now. And offline, when compared to offline, online is taking the more time. So today's class is completed. Tomorrow we are going to discuss the expression for the volumetric strain under triaxial loading that we are going to discuss. So write down the questions on based on today's class. So those you are not completed the principal stress chapter questions, whatever I have given, that you complete it now. We are not taking 6, 7 hours at a stretch now. We are giving a break after 3.5 hours now. Half an hour break you are taking now. After attending what now? We have started 6 o'clock, 6:15. Now it is 9:15. Can't you attend the 3 hours class now? If 3 hours class also you are unable to attend it now, then there is no meaning for Mr. Sinha. Question number 5. Question number 20. Question number 29. Question number 36. Chapter number 2. Question number 4. Six, 7, 8, and 20. So today's lecture is completed. These are the questions. And chapter number 7, the questions, whatever I have given, those they are not completed. Yesterday got the full 1 day gap, we got it. No? So complete these questions. Tomorrow we are going to continue as usual morning at 8 o'clock. 8 to same timings are going to be there. Tomorrow we are going to meet at 8 o'clock.